This is Alejandro Alonso, and I would like to share with you one of the projects I am working on at this moment. It's a general purpose autonomous mobile robot that could navigate either in free navigation mode based on SLAM using this LiDAR, as you could see here, and also could navigate following magnetic bands using this magnetic band reader. Is an option that it has. Let me share with you the architecture of this vehicle, and here, as you could see, there are three elements in the center of this architecture where all the decisions and actions are taken for controlling the vehicle. So we have here a safety PLC that is responsible of taking the control over the rest if it is necessary in case there is an imminent collision detected by the safety LiDAR, or someone has pushed the emergency stop button. So it actuates directly to the drives and the motors. So even if the PLC has a problem or the PC or whatever, it will take direct control over the motors, and you could reactivate with the rearm button. The PLC itself will take control. So this is something dedicated, fully dedicated for the security or the safety of the vehicle. Okay, and this one, the PLC, will take the control, or will actuate directly to the motors and get the feedback from the encoders to ensure adequate behavior. And also, if the vehicle use these two sensors, the magnetic band and the RFID sensor, in case you want to use this vehicle for a magnetic band following system, like this quite used in some factories. In that case, we use directly the PLC because it is quite reactive system. Depending on what you read here, you actuate here. Also, the battery sensor is read from here. In the case you want to go further and do something more powerful, like free navigation based on SLAM or things like that, we go to this PC. This is the one who takes the higher level actions or decisions. And some other sensors could be connected directly here, let's say depth cameras or any other kind of sensors, and it is also connected to a Wi-Fi radio. So we could connect that to any Wi-Fi, and through the Wi-Fi access, let's say, for example, if you want to go to Amazon Web Services RoboMaker, that would help a lot, because for the purpose of this project, I am thinking on having here in the first step ROS 1, in the second step ROS 2, and for sure connected through the Wi-Fi to Amazon Web Services RoboMaker. The HMI would help the interaction between the user and the vehicle. So having said that, I would like to show you a bit more about what is inside of the vehicle. So let's take out all the covers. Okay, you see here the HMI, and this is the emergency stop button, the rearm button, things like that. So basically, the vehicle has in front of the vehicle, you could see this LiDAR. Okay, it's a safety LiDAR, and here you could see the magnetic band reader is an option, and at the back you could see here the computer. Here you could see the PLC. the PLC I have here is just a familiar one for me. I'm quite used to use this PLC, but there are many other PLCs in the market. And here are the motors and something and the drives here. So something I would like to show you about these motors is that they use a balancing system. This is something, so the vehicle is supported by these forecasters, and these wheels, the traction wheels, could go up and down. So is this kind of balancing system is quite used in the typical robots at home for the cleaning robots, okay? And also there is a kind of very simple clutch system that activating this lever, you just move the full traction system up, so you could move the vehicle just pushing it, because the wheels, the traction wheels, will not touch the floor. This is one of the optional RFID readers, and there are many in the market, used a lot in different kind of industrial vehicles. And more or less that's all. Is quite simple vehicle. You have here the safety PLC is just so, and very commonly used from SICK brand. And for this specific vehicle I used a kind of industrial Raspberry Pi, but you see there is a lot of space for any other kind of, of computer, of industrial computer you would like to use. Here are the batteries. So if I take out all these units, I could show you that the batteries are there at the back. And here there is a kind of spring for this balancing system, so it allows the motors to go up and down with the full traction unit. Okay, these are the encoders. And that's all, not much more. You could add a lot of things to this vehicle, because there is a space. You could put whatever different actuators with motors inside, or more batteries if you need the vehicle to go to be used further. This is a kind of beam area, so the beam from the laser could go through here. So in case you want, I don't know, for example, here you see the beam. Okay, this is a simulation of what would happen with the beam and the vision of the vehicle. So that's the idea, pretty much the idea of the vehicle. It may support, as it has been designed, up to something like 80 kilograms or so, but just changing some small things, you could go to higher weights, and you could access everything easily from the outside. It's very easy to mount, very easy to maintain, and that's all. It's just I wanted to share with you my last design. Okay, thank you.